Okay, we're now recording. This is our last night of instruction. We're learning inline assembler. This is the code that will work on the Jeremy box. So I guess I should put that in there. Demo of inline answer for Intel on mkll.org. Some of you are saying, hey, I'm getting an error when I log into the Jeremy box through HTTPS. It is an error. The certificate expired, but we have two IP addresses, an internal IP address for jmkll.org and an external. If you log in to do HTTPS at jmkll.org on campus, you won't get that error. That is a warning error. It should not stop you from working. Just say, accept the risk to continue. It's just an expired certificate. And I have to jump through major hoops to make it work. So I'm going to wait till a break to do that. Okay. Next week, I will have the grades all posted and ready to go. So if there's some stuff in there that you're not happy with, or you missed some work, come on in on Tuesday night and we'll arm wrestle and we'll get your grade to where you want it to be. Okay. So if you want help and you really do want to learn this stuff, that's what it's for. So the final is about catching up work you missed. Okay. All right, let's see if this works. Really simple. And sure enough, it works. There we go. All right, now your mission is to take this code, put it on the RAS5 and find out what you need to change. What's the add statement for ARM64? Oh, that sounds like a good Google prompt. Will it be this simple? It could be. You'll have to connect the dots. This is Lego pieces. I'm thinking you'll be able to do it, although maybe not. We'll see. Are you done yet? How many are done with both of them already? Okay. Yes, question.
Have an error return to zero line.
Oh, it's always the computer's fault, huh? I'll bet you anything it's a typo. And it's when you get an error in C and it says this is where the error is, sometimes it's the line before because you forgot a semicolon or a double quote or a paren. And if you're using VI, if you use the % key, you can bounce between your parens to see if they're matched. Okay. And that works with any, so you just hit the % key and it bounces between the two. It also works for square brackets. No, it doesn't. Only works for parens and squirrely brackets.
No, yeah, I don't think it's
That's a pretty print. To do pretty print is pretty simple. What you do is you open your VI file and then you type in G, G, which means move your cursor to the very beginning. And then you use the equal sign, which means auto indent. And then you give it the language that you want it to do for C, and it will default to C. C is the default format. And then you just type in uppercase G, and it will automatically pretty print your code. The style guide is built in, so to speak. There's a bunch of different ways to do it. Is this big enough for the back? You need binoculars? You can make it a little bigger. That better?
Add the percent to
Annex point. Yeah.
So is the sum supposed to be 20 or 30?
What do you spell?
30.
Yeah.
But
Wait a minute. I said we were getting 20 on the answer, weren't we?
Yeah. I got 30 on the back with 20.
So we're getting 20 is the sum, it should be 30. Just a second here.
What's the percent of? But yeah, 70% too.
See,
Okay, so this first one. So it's a sign. It's through the sum of the points you're adding.
Yeah. we didn't figure that out. I changed one character. Now, why does that fix it? This is the bad code. And then this is the good code.
Because adding both of them together, not just calling out.
Yeah, you kind of have to consider 0, 1, and 2. We have 0, 1, and 2. So basically, it's positional, like our argument strings in the lab 5 we did, where we have argument counts. And we have our first argument, second argument, and we add them together. That's basically the fix. Okay. So when I run it, I get the right answer. Now, what I would recommend you do is comment the snot out of this thing. Because this is the takeaway from the one, this is the takeaway from the class that you could possibly use in industry. The inline assembler. Okay. In my 30, 40 years, I think I only did this twice. Okay. So it's not very common, but it's like not having the right tool. The job comes to the stop because you don't have the right tool to continue on. So this is one of those things that needs to be in your toolbox. How do you do inline assembler on the hardware of your choice? Okay. Because it will change. Okay. And there are other corrections on this to make it more production ready. Like there's a volatile keyword and there's some other flags in there, but we're going to leave that out. We're going to keep it simple. Okay. So I recommend you comment this and try to explain how this is working. Okay. Bring it in the debugger and watch it. Okay. Declaring our variables, printing the results, and then what is this actually doing? What is %1 and %0 and %2? What do they actually represent? We know 1 is wrong. What if I made it 0, 0? What do you think would happen? Any guesses? What?
0.
0. Well, if I make the 2 a 0, when it was 1, it printed what? 20. What do you think about print? 10. That's what my guess would be. So let's see if I'm right. Ah, did I change it? Yep, changed it. Didn't work.
Wasn't it adding 10 and 10 together? Isn't it adding 10 and 10 together because that's the first slot?
Yes. So it should be, so we want A, so it'd be 1, 1. 1 gave us 20. Let's play with it. See what happens. What are we gonna do? Break something? No, who cares? Okay, there's 20. Whoops. Come on. So I'm making it backwards. Notice we're printing a single value, right? This equals R. Okay. So what we're saying is, hey, go to 2 and print it. Put it in here and print it. So if I run this, I get the number 2 or number 10. If this is a 1, I get a 20. If I make this 2, 0, I get the addition. So write those codes in and make some comments to it so you can remember this stuff. Very obscure. So what does 2, 2 do? This is how I learned to code. You just tinker with things until it breaks or until you fix it. So I'm getting the right answer now. So now let's change this to 11 and 22. Working. So add comments. All right. On the Raspberry Pi 5, you'll need to make a change. Okay. I'm really surprised we haven't melted my raspberry. But what I would encourage you to try is move those numbers around. We got 2 and 0 and 1. Change them around and find out how they work, which one is B, which one is A, and which one is sum. Is it %0 or is it %2? And then comment that accordingly. And remember how the Intel works kind of backwards with the percent. This is the gas format, not the MASM format. And I've got it working on the Raspberry too. Now, did everybody get Lab 9 working on their Raspberry? No. So who did? All right. You had to change some assembler lines, huh? Once you change the assembler lines, you can get your Lab 9 to work just fine on the Raspberry. So not much of a change. And I will help you with that one because it's rather obscure. This one isn't quite as crazy as far as making the ad work on the Raspberry. I want you to notice the one piece of data that makes it work on the Raspberry Pi is that little tiny single quote. That's what made it work. Now, if you can't figure out Lab 9, it's your own fault. There's half the answers. All you have to do is go through and change the code to make them all the same. Okay. So I use bang for exclamation point. You can use semi for semicolon. I think a number 427. Same thing. We've done this previously. Okay. This is the kind of stuff you will forget. So I recommend you post it on GitHub somewhere or save it somewhere so you can find it. Make your own personal AI agent that goes through your hard drive, and you can do that. You can run an LLM on your own hard drive and use ChatGPT or whatever on your own notebook to help you learn what you've already learned if the data is somewhere on your notebook. It's kind of cool. A little creepy, but it's cool. Yeah. No. You're giving it up. So the real way to do that is to download an open source LLM and then run it against your own data. Yeah. Hugging Face is where you can get models. So what are you going to turn in? You're going to turn in the code, a screenshot of it running on both machines. So this is Lab 10. Okay. You should be able to get this done tonight. I hope.
So you just want the GCC line and then sum 30 for each one?
For both machines, yeah. Because I want you to know the difference between the assembler line on RAS and Intel, so you can remember it.
On this one, we don't put a %1 because it automatically assumes that 2 and 1 are connected, right?
That's of the function of this command. The add long. It's a function of it knows what's happening based on the positional characters. It's actually putting them together. So Raspberry is a little different.
Yeah, Raspberry, I put 0, 1, and 2.
There you go. Not hard, huh? We have a success. Yay. We did something in class that everybody got. Yay. The two things you'll need in industry, inline assembler and the debugger. Yeah.
So why is it that architectures are so similar but different?
Long discussion goes here. Risk. Reduced instruction set computer. Complex instruction set computer. No, they're both fairly complex. But what this means is the assembler is simpler. There's not as many things you can do. So your assembler code is typically very long because it has to do lots and lots of things. Your assembler code insists to be a lot shorter, but each command is very dense. One command can do some crazy things. All in the sys. Like I remember one that I had to use called DTA, data transfer address. The DTA allows you to move an entire block of memory from point A to point B. Boom, one command. RIBs was like 30 commands to do the same thing. But this one, so because it doesn't have to do pipeline with the complex instruction set. So I found this fellow, he's a German fellow, and he created an algorithm. Like the most common word in the human in English is this word.
Yeah,
%2.
That is also consistent across other languages. Other languages have the equivalent of. That's also, it's a fun read. Yeah. Since you're a stats major, it's gonna be right down your alley. Looking at, you know, how.
Look into this, I appreciate it.
Yeah, you'll have fun with that one. That'll be like if you happen to know another language, run this type of counting or a codec in the world of reading and writing. There's something called Gulch. So I can give you 100 words, and it's like 85% of all written language using those 85 words or 100 words. So if you look up Gulch words, what this does, it's great to help beginning readers. If you're English second language, if you start with the Gulch word, you can almost start reading right away because these are the most common words. The top 100 make up, I don't know what it is. You could do a search on that. The top 100 Gulch words makes up what percentage of English? It's like 80, 90%. Really high.
It's actually kind of cool. How did we find this proportion?
Counting.
Really?
Yeah. Well, look, this guy used the codex. He would use Shakespeare's plays, or he'd use books that were actually written. But you can expand it out and let's say, let's use a library. Let's use medical textbooks. Let's use math textbooks. It begins to fall apart when you're using a lot of different type of technical terminology that is unique to that discipline. But when you're talking about novel, newspaper, normal day-to-day reading, it's a pretty handy little technique.
So it's basically saying that as you progress in language, basically everything's going to say because it's essentially like.
Well, what this does is it speeds up your learning process because there's Gulch words in every language.
Yeah, those are words that you understand. So.
Yeah, so if you memorize the top 100 Gulch words for Hindi and you can say them and you recognize them in print, Well, now you're only having to worry about the big nouns and verbs, which is just glossary acquisition. So when you're teaching beginning readers, those words are very handy. It's also great for spelling. But English second language will always start with this.
Yeah, that makes sense. That's why
Yeah.
people that come in and they broke English, they say one word at a time, or they'll say one main word. That makes sense.
Yeah.
It's pretty neat.
Yeah, there was the guy that won the French crossword puzzle. Memorized
What?
the French dictionary and can't speak a word of French.
That's
He's known for great exploits of memory. So he's like the memory champion on the planet. But imagine memorizing a dictionary to play crossword, but it's not.
Yeah, that's
Zero.
It's like, what?
yeah,
That's
that's
10.
crazy.
That means one.
It's like the equivalent of like knowing every single command, but you don't know how to use them.
Right. Yeah.
And then.
Yeah.
So the only thing that actually happens.
And that's basically this.
2, 0, 2, 1.
This is the difference. Risk has much fewer words. You just have to write more of them to get the same thing. Like on his tenant, he says, yeah, I know the $30 words, but I prefer to use short words and more sentences.
Either.
And it forced it to bring his writing tighter because he was writing. He basically wrote as a fourth different level, but his stories were great.
It's assigning
So,
zero. So much. I don't think that's
Yeah.
pretty-
Zero,
Fun
some
stuff.
plus some doesn't have a
But
value.
translation is going to be the thing. That's a
That's the thing.
real-time translation.
So if we would do that,
The communicator.
why would it make sense? If that would be 10? Because, like, we do, um, we didn't really experience the way that the order thing, because so like the order
Is adding this one to this one. And then. And 1 and 2, that's what you can say.
for some reason, like theoretically, so you're like,
Top 100 words is 50% are written in English.
So how did you find out what the term was?
The what?
How did you find out what the term was? Yeah, like how did you figure out what those words were?
Oh, the fellow that invented it, his name was Dolch, and when he was a reading teacher. And they call them sight words. Words that you just memorize and you recognize them by sight. But he was helping kids learn how to read, and he found that a lot of the kids get stuck on these short words.
Yeah.
You know, the bigger words they can sound out. That's really hard to sound out. Yeah, it's all there. You know? So, but this is from his research teaching.
Operators are swapped. That would imply that 1 and 2.
How did you come across that?
I'm just like, I was labeled mentally retarded.
What?
In 4th grade, they labeled me. So I spent a lot of time proving everybody wrong.
Definitely did.
So I'm maligned. And I'm scared to prove it.
That's pretty cool, actually. That's kind of inspiring.
Yeah. It's, you know, learning how to read with one eye, that was very helpful.
2 and then 0.
Because I would read with one eye,
That's 2%. Which would be
but there was something about how my eyes
And then
focused.
the result.
They would come together and break apart.
So
So the words kind of would jump around the page. So reading with one eye solved the problem. So, yeah. And I still can't spell very well. Spelling is still a problem. Writing in general is a cognitive task for me. Some people can write, just let it, just comes out. I'm not that way.
Oh, what's wrong with my foot? It was like a really weird explanation.
That's still super impressive, right? So you overcame your issue.
Yeah, which is hard work. There's just, you know, when I get students that are dyslexic or ADD or whatever, I don't care. I'm that too. You just have to work 10 times harder to get where somebody else is. But that hard work is the one thing that gets you your success. Practice makes perfect. No matter what topic you get, the more you practice, the better you get. You know? So if you don't practice, you're gonna suck. That's simple.
So maybe because like maybe the
So if you got your Raspberry Pi done and this was done, you can turn in work late. If you've missed a lab or two, I've opened up a few of them. So if you want to redo them, feel free. And then all the grades should be updated by next week. And you'll know what your grade will be at the end of class. Personally, I hated knowing, you can go. I hated doing a final like math and then never knowing what you got on that final because the professor would use the same test the next year.
That's my biggest pet peeve.
I hate
That's
that.
my biggest pet peeve.
That's why I do all that stuff ahead of time.
So when the lab 6 came in, like it was missing, despite having all A's and other assignments, if I could drag down that I wanted to do, if I did have a bad grade on an assignment, would it drag it down the same way as that? Because I don't really know.
It's just straight points.
Okay.
So I just do straight points. Points you earn, total points, divide.
Okay, that makes sense.
So that. But was it 6A or 6B?
6B.
It's opened up to the 10.
Okay,
So you
I
can
have
put
already
it in.
turned it in, the new ones, but when it did drop, and it dropped from the overall grade from an A to an F, it was like, oh.
Well, that's because at that point in time, the grade book works on relative. The Canvas grade book does some trippy math. There's a little switch. It says treat ungraded as 0.
Okay.
You can turn that on or off.
Okay.
So if you turn it on, everything that is not graded shows as a 0,
Okay.
which is part of the total. Because when I was in school, I would always say, okay, here's the total points. So I start off the class with an F because I haven't done anything yet. Well, if I do that in class now and tell students everybody's got an F, they don't do anything. So that's why the grade book shows you at this point in time, you have an A, at this point in time, you have a B, but then people get lazy and don't do things and they wonder why their grade's an F. Well, you stop working. So
Okay, that makes sense.
trying to explain it, yeah. All right.
Okay, so I'm trying to understand the logic that's behind the registers here.
Mhm.
So I went through and I did all the different combinations,
Mhm.
and I cannot find the logical connection, right? So like if you do 0 and 0, they are the same being added together, so that would imply that those are 10.
Mhm.
But when you do 0 and 1, that is also 20, which is two different things.
Mhm.
So if 0 is 10, 1 would have to be 10. But 1 would either be 20 or just the int space percent.
Mhm. What you need to do is look up the add L command in Intel assembler.
Okay.
Start there. That will give, and then you'll see how, okay, when I want to add these together, because there's only 2 parameters on add L, where's it go? Where's the third one? Where's the result kept?
Okay.
So look up the Intel add L function or the command and find out the parameters and then play with that. Once you see how that works, then this will make sense because we're doing it inside of C.
Okay.
So we're using the positional parameters to kind of make the assembler behave. So start with Intel 64 assembler, add L, and look it up. See how it works. Maybe even write a short little .s file.
profit.
Not to the same thing, but to get my teaching. That's 3 characters and 3 names. 6 times. So you have explain values. So you have that man, you don't need dollar values, Are the copies or opposite products? So you do. They're exact copies of your explain, you just need to change them. Explain. Well, whatever. And you can really quick.
No. I opened it up to the 10, so you can do it. I won't take off for later. Oh, that's because I haven't finished grading them. Yeah, I'll get that done by next week.
That's what I was thinking. That's not. I think the performance is I guess I felt like my king was cool. Yeah. It's something related to something. So that I'm everybody can put out this without saying Wow, if I knew that earlier, then this seems, I read that if you sell me fire. So I'm reading this, and it backs what I was thinking, but I really not the result. This is as the source of the destination. From the source. It's not clear. Yeah, I know.
For the lab 8, you just want us to compile an fname.c where you type your name and it says hello your name into RAS5.
Yeah, but I want you to turn it into assembler
turn it into assembler.
and then clean up the assembler, delete all the stuff that you don't need. And then it's to show you that exercise is to show you, you use GCC to create the assembler. Then you use AS, the command, to assemble it. And then you use GCC to link it. That's the exercise in that lab, the sequence of steps. That should show up in your comment somewhere. All done?
Yeah.
Got it all working? Great.
I just want to ask a quick question. So you said that you mentioned that you were going to start grading it this week. or
Yeah,
next
I'll get
week,
it
you
all.
said?
Yeah, I'll get it all.
I was gonna ask, do you think there would be like any chance, like say that like I noticed I get like a low grade in between the time that you said that you would grade it? Do you think there would be a chance that I'll be able to meet up with you and remake that grade?
Yes, that's what next week's for.
Okay, cool, perfect. That's great. Cool, perfect. Have a great day, and I appreciate you showing me that. I'm definitely gonna research on that. I started trying to make. I started looking into the website that they showed us on the back of the flyer, and it is some really cool stuff. Like there's so much data to just sift through, and I was like, holy cow! Like, I didn't even know they could collect all this kind of stuff.
Oh, yeah.
And then what they did is phenomenal. They made it into like models, like you could like, and they're like, what's the word? Reactive too. Like you could hover over and see everything. I think it was really cool.
Oh, React.js. Yeah. React.js is a library that's used in JavaScript to make things come alive.
Yeah, I was like, wow, you could hover over it, interact with the data. It was super cool.
Yeah.
Definitely a cool experience.
That's the future.
Yeah.
It's going to be pretty cool.
Yeah. Yeah, I appreciate you showing me that. It helped a lot.
You bet. You're going to have a lot of fun.
Thank you so much.
You bet.
Have a good day, Professor.
You too.
How do you do the command to see the program? There's something to use. Yeah, but that's specifically execute.
So x86.
Yeah. I'm looking for support. Only thing I forgot, I always start these words. Yeah, that.
So ELF 64-bit LS.
So I finished the lab, but I just had a
quick question. So when you're pushing in assembly structure, pushing is that for inserting an element? And then when you pop, that's retrieving the element. So that's basically what's happening. When you're in that instructions happening. Okay. I just want clarification on that.
Yeah, that's what you're doing.
All right. That's it. Thank you.
You bet.
At source to destination. So that's implying that adding 0 to 0 and storing it here. How I also understood add prior when we read this in assembly. So this would be add 0 to 1 and store it in 1.
So. 0, 0, that means we're just skipping over. I'm pretty sure 0 is supposed to be something. That's the only thing that makes sense. So, one
Unless
logical
it's flipped.
conclusion.
It could be flipped, 2 could be sum, and 0 could be 10.
So that would be some. 0 was.
So then 2 and 0.
Mm-hmm.
We have classics.
Yeah. And it's basically, if you're happy with your grade, you don't have to show up.
You should have 1, 2, 3, 4, 5, 6, 7 headers. 1, 2, 3, 4, 5, 6. And then
Well, I don't have a 6, I only get 5.
you do 6. You have a number, and you need to go down and print them all out. And then that should be great.
So return.
Also, I tried that, given what we felt that 160 for the which is. It's worth it, that it-
Mm-hmm.
So for the final, we just do like, we could redo labs.
Mm-hmm.
So 2 of them are still locked right now.
Okay, which ones?
6A and 4.
6A and 4. There's 6A, it's open, and I'll do 4.
So that's basically it's like a 5 goes. Imagine you have 2 joint blocks. Another plug with a different number. Let's say you have something that you add
Take
the
it
number
easy.
on the first block, the number on the second block, and then you put the result back on the second block. In computer terms, also add that other take
Yeah.
2 numbers, you just sort of places in memory.
All right. So both
add them together and then store the
4 and 6A are open till the 10th. So next week.
The 8 below assignment, that was just the note card thing, right?
8,
Like 8 below.
the 8 right held on F thing.
No, no. No, it's just called like 8 below.
So
Oh.
you had 2 blocks. The first block has 3 on it. The second block
Right
has
hello
4
F
on it.
name and C.
The added
Yeah.
opcode had 3. The first block took over the second block, and the second block
This one.
now has 7 on it.
Oh, a hello. Oh, that's just means you just come by and say hi. That's all that means.
I mean, the old stuff, right? The video, the thing that was just new.
Yeah.
For that one, we were just supposed to look that up ourselves, right? 'Cause
Right.
I watched the video like twice and I couldn't find the answers.
No, there's no answers in there. You have to go look it up.
Does this look right for these four? That's what I submitted.
I told you to send like as a 5-year-old, because maybe that's what I
Yep.
needed.
That's good for that one. And yep, 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 yep. All good.
All right, thank you.
You bet.
Yeah, the letter of rec, you're gonna look at. I asked you for like a letter of rec. I need to-
Oh, did I?
No, not yet. I need to send the thing for.
Oh, okay. When the link comes in,
Yeah,
it's just for a scholarship, right?
yeah.
Yeah, the MJC scholarships.
Yeah.
Basically, once you get the link sent to me, it's like 3 sentences. So it doesn't take me very long to do.
Okay.
Because it says, how long have you known this student? What capacity have you known this student? And then they ask, what are your likelihood of success?
Okay.
You know, so it's pretty generic.
You're gonna.
So
Uh,
so you did send it to me?
not yet. I need to send it out. Would it be possible to, like, you'd be able to do it before like the school year ends?
Yeah, if you get it to me, as soon as you get it to me, I'll do
Yeah.
it.
All right, thank you.
And try to put the subject line very clear.
Do I need to like send you something from?
Well, what you do is you go to the MGC scholarship website.
Yeah.
And then you do that, and then you put my email in
Yeah.
to send me a link.
Okay.
And then once I get the link, I fill out the information and it goes to the scholarship office.
But like, I don't need to send you like, usually they ask for high school, they ask for like accolades, like my accolades, like info about me. I don't need to send you any info.
No, you'll type in a few things,
Okay,
but basically I'll get a link that's different.
okay, thank you.
That
Make sure that I explained 3 questions, you did like to explain.
all of the shortcuts on C. Change to between 4, 5, and 6 into oh.
We don't have that. You said like we had extra time for the labs, right?
Which ones?
Is there any way you could open up the video assignment that was due yesterday? I was
Oh.
sitting there. I had it done. I was sitting there at like look at the clock. It was 12:30. I was like, all right, well.
Yeah, let me open that one back up.
And then
That's the same as all the rest of them. So it'd be, you'll be able to go to the 10.
okay, cool. And then it's not all graded yet, right? Like all the like I think it's like 5 through
Right.
ungraded so far. Okay. And everything else should be good except for that. And then yeah. Okay.
If you get everything turned in, the likelihood you'll pass the class is pretty high.
Okay. I'll still probably be back just in case for
Yeah.
whatever reason. But yeah.
Right.
Bet.
Over here. Over here. Yeah, so you rebuild the regular stuff, but you go through all your HNS and make sure you get your die. Die 5 on each.
How would I take off?
Like we're missing a character from the 4, 5, 6, 4, 5, 6. So return 4 maybe? That's not gonna be different. This. Oh, I should have used it. H. So the prefix is the $C. For those last 3 changes to $I. Oh, okay. Okay. Yep. So clean. Yep. Dog tire. Dog flash. 4, 5, 5. Down. 4, 5. Was that the 6 on the PNC? 6 IS. Yep. Oh. Yeah, I don't know, basically. Submit all that code. What is this? You gotta do running all of the S file, all of the H file, the C file, all of that, so you screenshot it. Same code or number 2? All of the code is the same except for the S files. The S files are only gonna change for your small. The S files are always gonna be right. Class, question and that's what, yeah, it says for on in RAS 5, right? This is your S code. You just need to go through and change, like you know how to change bang or explain to something else. Instead of bang, it's gonna be. Okay. And you're gonna. But that's the code for the S. Yes, this is the stuff the professor provided. So all this code should be. That's for the dot H is the same. The dot H, all the header files. This is different because it's different. Let's take a picture of that.
Do you want me opening up the hexadecimal?
Oh,
That's from forever ago. I thought I turned it in, but I guess I didn't. And then lab 9, what do you want pictures of or PDFs of? Do you want just the code running, or do you want the code running plus the make file?
9, I want to see basically how the lesson learned from here is your S files
Okay. Yeah.
and how they're different between the RAS and the
And
in Jeremy Box Intel.
I also.
But what I'd also like to have you do, if you have the time and the inclination, is to strip out as much of the noise as you can
Yeah.
to where you get, let's see which one. This one? Yeah. Where you get a very minimal
Okay.
S file and then assemble it. So the steps that you've learned in 5, where you do the GCC to generate the S, then you use AS to assemble it, and then you use GCC to link it. Those are the 3 things, the 3 steps. How do I get my assembler, clean up the assembler, and then assemble it so that they turn it into object, and then link it and run it.
And then do you want, what do you want me to turn it?
When it runs,
Okay.
a screenshot of it running, and then just a shot of your code, blah, blah, blah.
Of the,
S's and the calling.
okay.
So in this case, in this case, I only did got my make file here. I did all tests and then exclaim and bang.
Okay.
Well, you're gonna have
I have like 6.
3, yeah, you're gonna have more, but the make file does the thing. And so the all tests is going to call them.
Mhm.
But what we're trying to learn is how to minimize because that's a whole lot smaller than the
The initial-
dot S that's generated.
Yeah.
So that's kind of what I want you to learn out of the assignment is when you generate your S, how much did you delete? And then you run through the AS to assemble it
Yeah.
and then PCC to link it and you're good to go.
Awesome.
Thank you, Professor.
You bet.
Are you ready to, open up that hex test one?
Oh yeah, let's do that right now. Let's
Hi,
do that.
Professor.
Yeah,
Thank you so much.
you bet. Have fun in your future.
Thank you.
When you make your million, come back and make a donation.
I'll keep in touch.
That would be great.
Did you end up getting extra RAM for that server, for the servers back there?
Pardon?
Did you end up getting extra RAM for your servers back there?
I don't think I'm gonna need it because the problem I'm gonna have. Whoops, I don't want that one. I want this. We're gonna be using a combination of KVM and QEMU and Proxmox. Take it easy.
Yeah.
To create a lab of,
All these
because
different-
kind of what I'd like to do is get the guacamole server working. And guacamole is an Apache tool.
Yeah, so I don't think I've ever heard of guacamole.
Guac.
Yeah, I can't spell,
Um,
I can't spell either.
What this does is it allows you to use your browser and connect to your machine.
Oh, any browser or?
Well, it depends. It's think of Linode, but you have one web browser
Mhm.
and then you could access any one of the servers back there
Seems pretty interesting.
or any one of the virtual machines that are running on the servers.
I'm guessing you're having a lot of issues with it though.
It's quite the slog.
Yeah.
They do not include binaries.
Oof.
You actually have to compile it from source and it's a Java app. So it takes a huge amount of, I haven't used Java in decades. I kind of, you gotta set the Java home and
Mhm.
you gotta get all the code, and then you gotta get all the dependencies. So it compiles. But it's slick. And then Proxmox is another tool.
Definitely seems interesting. But Java is crazy.
Yeah, it's not my favorite tool for such things. But what this does is this,
Personal
it's
environment.
similar. The best way to describe Proxmox is it looks and feels an awful lot like vSphere.
Yeah.
You load it on your server and then you can drag your VMs to it, or you can create your new VMs.
Really?
And it works. VMs will work from VMware
Mhm.
or KVM.
Which makes sense.
So you can just drag in your VMs and manage them all
That sounds a lot
from this environment.
sounds a lot easier than
Yeah, this actually sets it up. And then with the guacamole, you would have a person, they'd get their login. When they log in, they'd get their one virtual machine that's completely there.
okay, that makes sense. So this one's more personal. This one is,
Right. This one is like, this is what you would use to connect to it. And then it's really slick, but I have an account with the Colorado Springs University of Colorado.
Yeah.
And what they've done is that once you're a student, you say, hey, I need a generalized Windows machine, and they give you a virtualization instance of it,
Really?
and it maintains state. So you can save your stuff there.
I wonder how much setup that took though.
That's, it's all Windows platform. They're paying out the wazoo for that.
Top dollar.
Yeah.
Not a manpower and time that probably took.
Oh, that's what I noticed with Windows when they brought out Microsoft Exchange. One Unix email server can handle 3,000, 5,000, 10,000 email clients without any problem. But the Microsoft Exchange, they said, oh, you need a full-time administrator for each 50 mailboxes.
Full-time administrator.
When Exchange first came out,
And when you think about it,
you're going, no. And this is the main reason companies are outsourcing email, because it's gotten really difficult to admin email. It takes a ton of time.
you think by now we'd have something better.
Pardon?
You think by now we'd have something a little better than
Well, I think what's going to happen is we're going to see SMS kind of take over. When I worked at Foster's, we had this really cool setup, and it was an external card that you plug into a PC.
Okay.
It was a modem card.
Okay.
And what it allowed you to do is that modem card, I had an email gateway.
Yeah.
So I could send an email to a particular box, and then it would deliver a message. So all my logging was
on the
captured by email, but then the email would go through SMS. And then I would get my message, say, hey, error, bad printer.
Mhm.
And then I could send an email back, a text back.
Mhm.
And then the subject line, I could say script 17. And it would receive it. The SMS gateway would take that, and then it would send it to the mail server. The mail server was polling for script 17. When it saw script 17 come in, it would run the script and fix the printer. Yeah.
That sounds so. It's just a mobile.
Well, the thing is, to do that now, you have to use Telegram or Hologram or Twilio. It's all cloud-based.
Yeah, I mean,
You can't do it internally anymore. You can't even find those cards.
which makes sense. 'Cause
And it's like, oh my gosh, because so everything's gone up into the cloud, but having the ability to send a short text to fix a machine,
is
that was just
monumental
awesome.
instead of having to pull up the code.
Yeah. It's like, oh, let's pull over and find a pay phone and connect the modem.
I'm so happy I was born in this era.
Yeah.
All right, well, you have a good
All
one.
right, take it easy.